We try to finish up the rest of the function is secant, tangent, and cosecant. Now, the secant here, you apply the same principle with the cosecant, but this time you should do cosine first before you do the secant. Okay. For example, they ask you y equal to secant to I plus pi over 3, for example. So you start with cosine because cosine is reciprocal of secant. So that's the way I do. I did sine reciprocal cosecant, right? You're not on your own. Okay? You check your homework. You see the problem something like this. So you start to do cosine instead of sine. Then you reflect reciprocal. Okay, using the analysis. Don't plot the point. Okay, you plot the point for sine on cosine only. Okay, this is yours. Because the same principle, I don't go over this. Now, we go over the tangent. So, in general, we know that tangent theta equal y over x, right? And in the one unit circle, x is cosine and y sine. Okay? So tangent equal y over x, for example, when x equals 0 degree, when the theta here equals 0 degree, tangent equals y over x, which is 0, so we can start from 0 right here. Okay? When the angle equals 45 degrees, so we know that this one is isosceles triangle, right? So this one tangent equals 1. So I mark 45 degrees, which is pi over 4. So the value of tangent equals 1 right there. Okay? Now what? The next one here, when angle equal 90 degrees, which is pi over 2, tangent equal 1 over 0, which is undefined. So right away, when we recognize this one undefined, at pi over 2, you draw the vertical asymptote right away. Right away. Okay, so pi over 4, pi over 2, different pi. And that one, pi over 2, 3 pi over 2 right here. And finally, you have 2 pi. And in this one, symmetrical pi over 2, then you get pi, and you get negative pi, and you get negative 3 pi over 2, and so on. Okay? Now, if you go back the negative one here, this one, if you go this way, this one becomes negative pi over 2, right? Right? Instead of 3 pi over 2, jump over here, I want to go back here. So when angle equals negative pi over 2, so the tangent becomes y over x becomes infinitive again, undefined again. So go back to the fourth quadrant. So this one here, infinitive. Okay? This one undefined right there. So this one has to be first quadrant here. This one here is first quadrant. This one here is second quadrant. This one is the fourth quadrant, third quadrant, and finally from here to here is the fourth quadrant. So this one go backwards, this is the fourth quadrant. From here to here is the third quadrant, and from here to the second quadrant. Okay, and go back from here to the first quadrant. Okay, so minus 2 pi. Okay, so now we wrap between the first and the fourth quadrant and see the behavior. You can see if I have a negative 45 degrees, then tangent becomes negative, because y over x, y negative, x is positive. So that's symmetrical for that point here. When this one here is negative pi over 4, the tangent becomes negative 1. So this one we call the odd function. F of minus x equals minus f of x. So this one here, the minus right there, is now become negative 1, which is minus of that x there, x to pi over 4, and become minus of f of x, which is 1, become a minus 1. So you mark here 1 and minus 1. So the graph symmetrical over this. Okay. So now, if you know the graph is odd function, you need to do only the right side, and you can reflect to get the left side through the origin. That is for odd function. So if tangent is getting bigger, close to 90 degrees, what happens? If the angle close to the 90 degrees, what happens to x? So right here, the angle here and here getting bigger. So the opposite almost one, right? About one, right? But this one here getting smaller. So here's the principle. The opposite y over x, opposite almost 1 over 0.1 equal 10. So now 1 over 0 equal 10. So this one get close to 90 degrees here. This one going to be 10. Okay, you come back here. If angle so very close to 90 degrees, so let's take a look at this. So the angle here is like 89.999. So then you plug in here. So now the x becomes very small. Okay. So for example, 1 divided by 0.01, which is equal 100. So this one 0.01 here. So 1 divided by that becomes 100. So the graph will go to infinity as the angle here bigger when before they hit 90 degrees, which is only 5. You see that? So that is the analysis approach. Okay, you don't need to plot any point. You look at the ratio of this over this, and it is getting smaller when the angle getting close to the 90 degrees. 1 divided by extremely small equals extremely large. So take a look. 1 over 10 equal, 1 over 0.1 equal 10. 1 over 0.01 equal 100. 1 over 0.000001 equal a million. A million. So that means the angle is super close, okay? And the x becomes super small, very small. And 1 divided by very small becomes very large. So therefore we know that the graph had to be go to infinity. Now what? We already know tangent and sine, the odd function, right? So how to find the other part? You just go to the every point here, reflect to the origin of the same distance here. From this point here, you go to here, and you go to here. The same distance, you get next point. And from here, you go to here, and you go to here, you get next point. And so on. And you go from here to here, and go all the way down here, then you get next point. Then you connect all the points together. Then you get the full period of tangent near to the origin. So the same argument, you can have the whole lot of them, right? So from here to here equal pi. Therefore, the period equal pi, not 2 pi. Sine cosine, the period equal 2 pi. Tangent, cotangent, the period only pi. So if you want to do some more, you can do like this. So you do the same argument here, like this, like this. Then you have another one, another graph of tangent. So you can do right here too, right here, and the graph go like this. Okay. So let's go to infinity. Usually we ask you to do only one period only. One, I introduce you how to graph y equal 3 tangent 2x. So first of all, we know the period of 1x equal pi. The period of tangent here, you just simply you take the regular period for tangent, you divide by whatever number here, become pi by 2. So now what should I put right here? I use the same graph. Pi by 2 means from here to here, pi by 2. The whole period, not from here to here, from here to here. Therefore, this one has to be halfway, pi by 4 here, this one becomes pi by 8 here, negative pi by 8 here, this one pi by 4 right here. Everything in half, so this one in half, this one put in 4, this one becomes pi, and this one in half, minus pi by 8, and this one pi by 4, and this one divided by 2, and this one divided by 2 get 4, this divided by 2. So the whole system shrinking in half, right? So each point here you already get there, you just divide by half. And you use the same scale. You don't draw the scale, right? How about number 3 right here? So this is the point. It used to be pi by 4 and 1, now become pi by 8 and 3. That's done. Perfectly the same right here. Changing only the leveling, the period, changing the point, but the graph stay the same. The last function analysis to grab the rest after we know. For example, there are two ways to do it. So we know that cotangent is reciprocal tangent, right? So equal 1 over tangent. So now cotangent is x over y. So now we recognize right here at the 0. X over y, 1 over 0 equal undefined. Therefore, write in the 0 here. Write in the 0 here. Okay. So undefined, let me separately with the tangent. So therefore you have to do the vertical asymptote, right? Y and this one x here. What next here? When angle here from here to here equal 90 degrees, cotangent equals 0 over 1, which is equal 0, x over y, which is 0. So right here, cotangent equals 0. So pi over 2. So okay. So now next one here is equal pi. When do we pi here? X equal negative 1, y equal 0, undefined again. So then we have another undefined right here. So therefore, we can see the period of cotangent equal just pi from in quadrant 1 and quadrant 2. Tangent in quadrant 4 and quadrant 1. This one quadrant 1 here and quadrant 4 here. So that's different. So how about cotangent near to the 0? This one 0, right? This one 0 and 0. Angle equal x equal 0 here. So what happened? So let's say pi over 4 first. Pi over 4 is 45 degrees, right? Cotangent of 45 degrees also equal 1. So if you mark from here, so you mark from here, this one, the function of tangent. So if we mark all together like this, so they share the point here. Because when we have 45 degrees right here, cotangent and tangent also equal 1. So in this case, right here, cotangent equal 1 right here. Okay? Pi over 4 and 1. How about pi over 2? We already know cotangent of pi over 2 equals 0, right? Because x over y. X equals 0, y equals 1. So right here, so we connect like this. Okay? How about near to here? Look like this, right? You always, the graph has to bend close to the asymptote. But let's see what happens. When the angle getting smaller this. So cotangent is almost 1. The opposite, x, y opposite gets smaller. So how about extremely close? So let's say 0 degree, 0.1 degree like this. So very small here. The opposite becomes super small, right? X over y. So x is about 1. Almost from here to 1, almost 1, right? When the angle gets smaller, x is close to 1, and y becomes extremely small. Extremely small become extremely large. Okay, so x 1 over 0.1 equal 10. 1 over 0.01 right here, the angle getting smaller, y getting smaller, and this, the whole thing, the ratio of cotangent getting very big. So x becomes 45 degrees equal 1, then 10 degrees, 0.1 degree is equal to infinity. Okay? Okay, so now how about beyond pi over 2? If beyond pi over 2, somewhere right here, so this one is symmetrical to here, like this, cotangent equal x over y. When you go to here, the symmetrical but x becomes negative of that x, so y stays the same. So it turns out to be negative. So symmetrical negative here, so we can mark right here, 135 degree cotangent equal negative 1, and the same argument cotangent go like this. So this one, another asymptote of the tangent. How about if you look it here? You look here. So now, this is a tangent. Graph tangent. Now I graph with the red, with the purple color for the cotangent. So reciprocal 1, here the value 1 here, 1, the same one. Reciprocal 0, okay, reciprocal, this one, y equals 0, right? Reciprocal of 0 equal undefined. So 1 over 0 undefined, so the graph go this way. How about reciprocal of infinity becomes 0? Because reciprocal infinity will let 1 over infinity equals 0. Not equal, but it's getting to 0. If this one getting bigger and bigger, the value tangent getting bigger, the value cotangent getting smaller. So we call tangent of x equal 1 over cotangent of x. So when tangent very big, this one has to be very small because 1 divided by very small equal very big. So tangent go to infinity, cotangent go to 0. And again, we know that this one equal reciprocal 0 equal undefined, right? So then from here you don't need to do anything else, you just take reciprocal of tangent here. So this one another vertical asymptote, right? Vertical asymptote right here. Now look at tangent here. Reciprocal of negative infinity equals 0. Reciprocal of big positive equals 0. Reciprocal of 0 equal infinity. So you go like this. Because the tangent equals 0, cotangent has to be negative infinity. Okay? So tangent equal negative 1 right here. So reciprocal negative 1 also negative 1. They share this point, they share this point. Okay, then from the tangent you still can graph the cotangent without swing the cotangent. Okay, so think about that and you can play around with it. You graph the tangent and you make a human, you graph the cotangent, or you look at the one in this circle, the value of x over y in here is undefined, in here 0, undefined 0. So between 0 and pi here, you draw the vertical asymptote because undefined, and you look at the value right here in the middle equals 0, and you make a human to graph the rest. Okay, so that is about cotangent. Two ways to do reciprocal tangent, or you go straight to cotangent. Now, how about to do this? So when I have negative 2 here, then I go backward. Okay, I go backward because you don't flip over there, okay? Then, so now the period equals pi over 3 because you divide pi by 3. So that means from here to here has to be pi over 3 because contingent from 0 to that. So this one halfway becomes pi over 6, this one becomes pi over 12. Then 1 pi over 12, 2 pi over 12, 3 pi over 12, which is pi over 4. Okay, that's almost there. So how about number negative 2 here? This one becomes 2, and this one becomes negative 2. So this one still 0, and this one graph of the second one. Okay. So now you watch it on, and don't copy from this. You pull out the paper and you write down the equation, and you look by yourself using analytic skill. Okay, to develop the way another way thinking about the graph. Okay, not plotting the point. Just use